All right, so last time in class, you guys had main task of showing a velocity graph of a pendulum, given some information, and want to kind of give you some guidance on getting it started. I'm not going to show you the whole thing right now. So, length L, we're told it's displaced to a position of 0.2 meters, and it's released from rest. So, that indicates we're starting at a positive position. So I just got it drawn to the right, positive to the right. And we're told that the frequency of the oscillation is 0.5 hertz. Well, we want the period to be able to draw this graph because we have time on this axis. So inverse of frequency, get a period of 2 seconds. Awesome. We've got to show 2 oscillations on this graph. What's going on? When we release it from rest, the initial velocity is 0. So that's a big clue right there. So got to start at 0 velocity on the graph right here. And then, well, which way is it going to move? Initially, it's going to be moving in the negative direction, so that's going to be a negative velocity. So what's going to, and it's going to get faster and faster and faster up to this point, up to equilibrium. So negative velocity, it's going to be, a line coming down this way somehow, right? We got a period of 2 seconds. We have to finish this cycle in 2 seconds, but in that one cycle, what we've got to do is, one cycle is down here to the greatest negative velocity, to 0, back to the greatest positive velocity, and then back to 0. That'd be one cycle. So we got to come down to the greatest negative velocity, and back to 0, up to the greatest positive velocity, V max, and back to 0, and that's one cycle. So it's got to be that kind of very poorly drawn, but you get the idea. And what's awesome is the nice even period of 2 seconds. So there's 1 second and there's 2 seconds. You want to smooth this out as much as you can. I mean, you really don't want to be sloppy with the shape that you're drawing. That's not my point right now. I want to get you started with this, thinking about this. Clues, contextual clues given to you. That's positive initial position. Cool. And so it's going to have an initial negative velocity. Cool. Now, one more thing for this one. The idea of Vmax and negative Vmax, right? So you can mark, you should mark these. You were told to specifically label maximum values, but this is not a value. I'm not showing you a value. So what do we do about that? All we got to do is calculate some Vmax real quick. So from the equation for velocity of simple harmonic motion, negative amplitude times omega. Now we don't have to worry about the minus sign right here. It's just that we want the amplitude times angular frequency, and so we know the amplitude was the 0.2 meters. Angular frequency. Okay, we got 2 pi times the frequency. But the 2 pi times the frequency is 2 pi times, and we got our frequency of 0.5 hertz. You do this math, and you're going to actually get a value for V max. I should put max here. You need to show that value here and here. Do not just write V max. You need to write the actual velocity value there and there. Keep in mind, this is negative down here. Right. Okay, so that'll get you started on this task. Try it out.